language. Charging these cases, and like I promised, I was going to take 10 of these cases and measure the powder exactly. I have my scale up here. I'm going to just take randomly a case here, a case there. Let's make it 10. Make it a good test. I hate individually measuring these things. It's just a pain in the butt. Let's see, where are we here? Look at so little difference. And I won't waste too much more of your time here by showing you the rest of them being done. Just take my word for it, and I'm going to keep these guys segregated, the exactly weighed ones, and then I'm going to put bullets in all of these cartridges, and then we're going to run our chronograph test. Well, we're back at the shooting range here, at least a piece of property that I can shoot on. So there's not going to be any gunshots in the background, not like Pearl Harrell or anything like that. We're up in Alberta, Canada, lots of room. So got this place to ourselves. I've got my chronograph set up over here, and it's a Caldwell chronograph. I've got my loads also ready. I've got 10 rounds of the ones that came straight out of the powder measure, and I got 10 rounds that are precisely measured as I showed you previously. So I'm going to start off with shooting 10 rounds that came out of the powder measure. I've got it hooked up to my cell phone here, so I'll start that. I'll update you on standard deviations and such as I can as we go along. How about that? So let's get this rifle. The rifle I'm going to use is a Ruger number 1, Varminter in 243. It's got a heavy barrel, so it's well suited for this kind of testing. And I've got my target set at about 20 feet away. So let's get this thing underway. That says 3025. These roads are pretty hot. That one says 3066. That's the 10th shot of the series. Now it's telling me here that I have a standard deviation of 20.97 and an average velocity of 302330. Minimum velocity was 2983, maximum was 3066 with a spread of 83 feet per second for those 10 shots. So, well, I guess we'll save this result. I'll start a new group here on the spreadsheet, and we'll capture some data for these ones that we precisely measured. Well, that was fun. So let's move on to the next batch. I've just got the 10 rounds left of the individually measured charges, and we're going to see what kind of a difference that makes. Get my program start of the year. And that should do it. Good work. So, 29.97. And for the 10th one, $30.29. Okay, let's see what we got here. What I've got is an average velocity of 3,018.4 feet per second, a standard deviation of only 11.46. The minimum velocity was 2,997. The maximum velocity was 3,035 with a spread of 38 feet per second. So that's actually pretty good. If I save this down, let's see here. Let's save this thing. Take a look at my other group. That was, well, let's see. So the previous group had a standard deviation of 20.97. Almost twice as much. So, you know, I might have to eat my words a little bit here. Those precisely measured rounds, cartridges were, those charges seem to be paying off, unless it's just a fluke here. I've got a roughly the same average velocity, but the standard deviation is quite a bit tighter on those cartridges where I hand weighed the charges. So maybe we can kind of crunch these numbers a little bit, see how much of a difference on target that would make, because for hunting purposes, maybe this is probably just still fine. I've got a lot of game just using the load straight out of the powder measure, but I think this is a learning experience, both for me. Like I said, I wasn't going to fudge the results or nothing, and the chronograph is reliable, it doesn't lie. So what can you say? Facts is facts, right? So let's go back to the reloading room and we'll take a look at this data a little bit closer. There goes a goose flying by right over my head. Well, we're back again in the reloading room, having gathered our test data and returned to take a look at it. And this is an important step in the process of running tests like this. I have a feeling that a lot of reloaders skip the analysis stage of this when they go out and they run their own tests. You know, I just went out and I spent a couple hours going out to where I go to shoot and setting things up and doing my test shooting and coming back. And you know, when I looked at the data at first, my results, the standard deviations especially, at first blush you can sort of, it's tempting to just draw conclusions right on the spot. But really, it's not as simple as that. If you want to really make good use of your data, you've got to apply some statistical analysis to it. And I don't want to sound too highfalutin, but, well, maybe I do. I'm going to put my glasses on to look smarter. But, you know, you do have to look at the data and try to determine were the results that you got a natural expectation of chance given the sample size, or is it statistically significant? Because in this test I shot 10 rounds. out of each set of cartridges, right? And just to refresh, you know, I got pretty close to the same average velocity, but the standard deviation in the loads that I measured just using the powder measure was quite a bit higher than the standard deviation from the loads that I individually weighed. So at first blush, when you look at that, you say, oh, whoa, you know, okay, that's pretty significant, right? But you know, if you look at it more carefully and see what kind of variation you can expect, and I don't want to get too far into the weeds of this, but I'm going to just post up here now what the raw results are, just to try to explain, because this is how we're going to get our conclusions from the tests. I'm going to dive a little bit deep into this, okay? So hold on. First thing, we're looking at the, on the screen there, you can see the one column is the powder measure loads. That's the ones I put out just with the powder measure. And then on the right column, that's the individually measured loads. You can pause the video and take a closer look at those if you like. But so that was the raw data that I was looking at out in the field there. Now, if we take that data and convert it into some charts, which I'll show you next here, then you can see we have the powder measure loads on the left and the individually measured loads on the right. And you know, looking at that graph, it's not like one is a whole lot more erratic than the other. So that's already starting to make a person think, is one load really so much better than the other, or one method of loading so much better in this case? So now we have to rely on a little bit of number crunching, some analysis. And as a side note, I'm going to post, I'll post a link to my how-to videos. I cover all this stuff. I have formulas explaining how to arrive at these figures. I also have even a video on how to convert your test results into graphs using Excel, all kinds of stuff like that. So won't get into all of that, but ask me in the comments and I'll point it out to you if you need some help in that area. But looking at this next screen here, this is where we have comparing two averages. And I'm just going to read this off to you. In the remarks, it says, in the case of confidence limits, the formula is based on what is supposed to be a single population. That's when you're trying to determine how reliable your data is, and that's partly based on how many pieces of data you have. So the remarks goes on to say, when you're comparing the averages of two separate populations, then their margins of error have to be combined if you want to compare those two averages. So the whole point of this here is saying, okay, I got this one set of data and I got another set of data. One has this standard deviation, this has another standard deviation, and they both have one average value and the other set of data has another average value. But you know, as this write-up goes on to say, and this is actually found, I have this in my reloading notes. I have my entire set of reloading notes available on video. Is the apparent difference in performance of two populations a result of error which can be expected to occur, or does the difference surpass the limits of chance variability? In other words, is the difference statistically significant or not? That last sentence is the real key. Is the difference between my two sets of results statistically significant, or can it be written off to mere chance? This is what you would expect to occur if they were both the same population. In other words, if all 20 shots had been shot with using the hand measured loads, or then I would have got the same results if they're statistically the same. Or if I had done all 20 shots using just a powder measure load, that set of data, if it's not statistically significant, it would look just like doing the 20 shots with the hand measured loads. So we're comparing two populations of data and seeing, are they really, do they vary so much that the difference is significant? So we go on into here and say, look at the formula where it's T equals the average of x1, the average of x2, that's our average velocities, over the square root of the two standard deviations squared. And I crunched those numbers and plugged in the values, and I arrived at a figure of 0.205. Now we can look down at that chart of T critical values that's also shown on this page, and that's taken from my notes, that shows you what are the T critical values for a given number of data samples. Now in the case of this test, I took 10 shots with each one, so the N value is 10. And that means that if my T critical value at 0.205, if that was greater than 0.664, it would be statistically significant, meaning, translated, they are totally different populations. That kind of variation cannot be accounted for by chance. But since it's far below that, these are statistically the same populations, the same set of data. As I said, they could have all been shot, 20 shots using the powder measure approach, or all 20 shot using the individually measured approach. So that is the hard truth that comes out of this. And that bottom graph there for analysis, it kind of gives it a little bit of a visual showing you where you have two populations, and depending on how much overlap there is between those two, that's how you determine your statistical significance. So the upshot of this is that this test tells me, after a careful look at the data, that there is no difference between measuring the loads individually or just making your loads coming straight out of the powder measure, following the approach that I showed in this video. So I want to thank you all for hanging in there. This has been a very long video. I tried to cover maybe too much ground, but my main focus was to cover the use of powder measures. And I'm speaking to an audience mainly of reloaders that are maybe starting to get into it or have questions about whether a automated powder measure device is worth the money or if they're better. A lot of people are saying, you got to have that if you want to do well. And I'm challenging that assumption in this video. And in order to do that, I really feel to give especially the new reloader a chance, I've got to give them an introduction on how to use a powder measure, how the thing works and everything to begin with. Even when it comes to the speed at which you can process a set of cases. So it's been a long run of a video, but on the other hand, I think I've covered all the bases, or I sure tried to. And even in spite of that, there are some things that I cut out because I just didn't want to get too far into the weeds. You have to cut it off at some point. So since I should cut it off at some point, as I'm saying, I'll take my own advice, and I hope you got something good out of this video. There's so much stuff in there. There must be something in here that you found useful, right? And there may be a few people that are strongly disagreeing with my results and saying, no, the individually measured method is far superior, but honestly, fellas, the test data shows that there is no difference statistically between the two approaches. So if there isn't, why not use the faster approach? Now you have no excuse for just not being able to use a powder measure because I showed you how it works, okay? So, from the Way to Native Chronicles, God bless, until next time.
이때도 내가 캐고있어 이게 나지 그 교材